Cool. I'm going to talk to you today about some architecting and scaling simulation software, particularly for the immersive metaverse. Now, first of all, who are we? My name's Matt Kemp. I'm a game director at Hadean. I've worked in the gaming industry for 20 years, mainly on MMOs. And Hadean are a deep tech company, got some really cool technology which allows them to distribute processes on the cloud. And that effectively means anything that you make on the platform, you can infinitely scale on the cloud. Now, when you take a whole bunch of MMO people, and then you give them a piece of software and say, hey, you can make some really big simulations, and the first thing that pops into our head is, what's the biggest simulation we can make? It obviously is the metaverse. So we have a dream of what the metaverse is. And I think it's a dream like many other people. You want to be in a 3D world. You want to be in a world with many thousands of people in it. You want to be able to have really good social interactions with people. You want to be able to wave at people, shake their hands, give them items, see them smile, see them laugh, see them cry, and have really positive engagements with them. Also with AI as well. You want to have the same engagements with them. You want to know the difference between an AI and a person, but you still want that good social interaction as well. And then you want to be able to impact the real world. So when I'm in the metaverse, I want to be able to see something I want to buy and have it delivered to my house. Great thing. And then finally, I want to be able to make an impact in the world as well. I want to be able to change it. I want to be able to create art, create music, create buildings, and make all these wonderful things happen. And that's the dream that we've got. But we're a million miles away from being able to do that right now. You're lucky to get, I mean, I'm glad people actually recognize this picture. The amount of people I've shown this picture to, and they're like, what film's that from? Anyway, we're a million miles away from it right now. We've got, you're lucky to get 100 people in the world. And as soon as you get 100 people in the world and you start doing things with them, that number goes down. The amount of compute needed to actually deliver what we want to do is huge. And you just can't do it. And right now, the only way to deal with this is through putting people into isolated instances so they can have their little world with what they want to do in, but not with the thousands of people. So why is this a problem? It's quite simple why this is a problem. As soon as your simulation requires more compute than one computer can give, then you have your problems. You have your decreased accuracy of interactions, you have your increased lag and latency, and your server crashes. And the way we deal with this right now is we decrease the amount of participants in the world, we decrease the fidelity of the world, we decrease the functionality and increase those isolated instances, and this is taking us away from the metaverse. This is not what we need. The way we solve these problems right now is not going to give us the metaverse. So how do we solve this problem? Obviously, we spoke about distributed computing. The way we solve this problem is we take a map. We divide it up into lots of little squares that are called cells. Then we apply a piece of compute to each cell. What we then do is we then divide the cells dynamically. So as more compute's needed in an area, we can then add more cells and therefore more compute to that area. So if you look at the image up here, everything's happening in the city. The city is you've got people running around, you've got cars, you've got traffic, you've got a lot more compute happening and a lot more resources, a lot smaller cells in that area. If you're on top of the mountain, you've probably got a Yeti and some snow and not much else going on. So you have a bigger cell, less compute. That way you can always get the compute to where you need it to be. And this solves these problems. These solve the problems of getting more users into the simulation, getting better interactions, higher fidelity, and then removing those isolated instances to get people playing together. But it brings its own problems. It's not a straightforward, simple thing to do. We've got to start thinking about other things as well. Because you're running off multiple machines, you've got to start thinking about how do you move data between those machines? When should you split and merge the data? How do you keep track of all the machines? If you've got 6,400 cells, that's 100 machines you've got running. How do you know which cell relates to what part of the simulation? And how do you know what machine it's on? How do you talk to each other to make sure all the information is going to the right place? And then over time, there's going to be more solutions to do this. There's not going to be one solution, there's going to be many that do this. How do we make sure these all talk together so that when you're going through the metaverse from one solution to another solution to another solution, it is a seamless, good experience that we want. So, data structures, our favorite subject. The way we look at this is you've got to think about the different levels you can put data at. So you can have data sitting down very much at an actor level, so all the data at the very bottom, or you can have data running on every single core, you can have data running on every single machine, or data running in the data center. Now, the ideal place to have all the data is on your actor, because that's where everything needs to happen, that's where all the processing happens. And if you want a proper performance simulation, you stick everything on the actor, but that creates the problem of I then have to move all that data every time that actor moves a cell, and that's expensive to do. And if you think that an actor might be standing on the border of a cell, it might be moving 10 times a second. Therefore, you have to move that data 10 times a second as well. And it could be from one machine to another machine, or even to a completely different data center as well. So the sort of rule of thumb we have when looking at this is the lower you go down the stack, the increased duplication you need, the more data you have to send around. But the higher you go up the stack, the decreased performance you get. But then your simulation isn't just your simulation. There's everything else that's got to plug into your simulation as well. So you've got things such as your physics engines, you've got your friend servers, you've got your player databases, all this stuff makes a simulation work. And if we're talking about not hundreds of people in the world, not thousands or tens of thousands, but hundreds of thousands and millions of people in the world, then suddenly the amount of processing power you need for all your different services might be bigger than a machine as well. So you have to start thinking about distributing all your services on top of all your simulations in order to make sure the world is big enough and has enough compute to power a metaverse world. So next problem, splitting the simulation. So we've got a nice simulation. The easiest way to split it is geographically. You split it into a 10 by 10 grid, but a piece of compute to each area, and there you are, job done. And that's all well and good until your users in the simulation don't do what they're supposed to do and all run into one cell. Beyonce comes along and says, I want to release a new album, I want to do it in your metaverse world. None of us are going to say no. And everyone's going to run into that one cell, crash your server because that cell can't cope with the amount of people in it. So the obvious way to split it is to start off by splitting your users. So where your users are, where they go into. If more users go into a cell, you can start splitting it down. Beyond that, you can then start thinking about what if your user can trigger a whole bunch of AI, can trigger a whole bunch of physics stuff. And potentially your user's not the best way to measure that. You've got to start looking at how you can measure compute, what other metrics are important to you in order to deliver, to split up your simulation the way you want it to be done. And then we have the next problem. So we've got all these machines running your simulation. We need to keep databases of all these machines. Now, when you start up your simulation, you've got it perfectly organized. You've got it so you've got all your cells on the same machines next to each other, so it's nicely performant. But as soon as you split a cell, you're going to get more machines coming in there, so you're going to start fragmenting your simulation. And then you get to a stage where it's so defragmented, your performance really starts getting impacted. And you can't go down the route of suddenly turning the metaverse off and saying, right, metaverse off for 8 weeks, run a defragmentation program. Doesn't happen. You've got to always be adjusting the metaverse and the service underneath it to make sure it's constantly performant, otherwise it will just grind to a halt over time. So then we have the situation where all these different solutions need to talk to each other. So what I've tried to do here is I've tried to sort of put together what might an open standard look like. Now, from the research we've done, from the experience we've had, when you start thinking about what data needs to be performant, you need to start thinking about where that data needs to sit. So if you're putting something in running on the data center level, that doesn't have to be a performant piece of data. It could be something where you are requesting information from a billing system, from friend servers, inventory systems. Alternatively, if you want something which is you need a bit more often, such as your physics or your AI processing, that may want to sit on every machine so you don't have to go so far to run that process. And again, on the CPU, obviously you want everything that's in a cell running within that CPU because you're going to need to know what's in your cell quickly. You're going to be able to want to message everything in your cell quickly, and you want to be able to sort of move from one state to another. Then we can go down a step even further. We can start looking at what data needs to sit on the actor, so things such as your user ID, your positioning data, your actor state, directional data, all that needs to sit on the actor. Core data, so your map data is going to want to sit on your core. Your data collection tools, because you want to know everything that's happening in the core as well. Entity positions, all your NPCs, where are they sitting? Then the machines as well, physics libraries, AI libraries can all sit on each machine, run off there. And then data center, like we said before, billing data, security data can all sit on the machines. So this slide I put together just to sort of really reiterate the point. If we're going to build a metaverse that has millions of people, hundreds of thousands of people running around it, everything needs to be distributed. We've got a nice distributed simulation, all your services are distributed, and you've got a management and discovery service which is distributed as well. That needs to tell everything where to send the information to. And if we don't distribute everything, we get a single point which is weak, then it will start falling over, performance will start being a problem, and the metaverse won't be what we want it to be. So everything has to be distributed. The problem's only going to get worse. It's not going to get better because we've got all this other new cool technology that's coming out that we want to put into the metaverse, and that's going to require more processing power. The more processing power we have, the more we've got to distribute what we've got, because we need to get that compute to where it needs to be in order to make sure that we're all performing the metaverse in the way it should be. Then I started thinking about decentralization and whether distribution and decentralization are the same things. I mean, conceptually they're not, but the problems they face are the same, because we've got all the different information around different places that have to come together, talk to each other, and that again requires lots of processing power. So one of the things that I'd like to talk to some people about today or over the next few days is this a problem? Can you really have a decentralized database or decentralized metaverse without distributing it first? So as far as I see it, there's three ways we've got to go forward with making sure we've got enough compute on the metaverse. First one, we segregate the metaverse, we silo it up, put it into little experiences. That, for me, doesn't work as a metaverse. The second one, and this one takes away a whole bunch of our problems. We can make the speed of light faster, then our problems disappear. But that's a problem for Einstein to solve, I think. Otherwise, distributing the metaverse across multiple machines is the way forward, which obviously the cloud is there to help support us in that. Thank you. 15 minutes. I'll sing a song. Yeah. So,
can you expand on decentralized and distributed research?
So this is the way my brain works. So if decentralized is where information is shared by many, many people around the metaverse. Now, if that's all in many, many places, then you've got the problem of how do I find the right places with everything in, make sure I can communicate to the right place, pull the right information from the right places and put it into a simulation that makes sense. And that's solved by the distributed systems that we have. So without solving that problem, can you have a decentralized thing without being able to communicate between them, without knowing where everything has to go at any one time? And again, I don't know the answer. I don't know if that is true, but that's something that when my brain sort of goes through it, I'm like, this seems like very similar problems. We might have already solved this, which is, be a good thing to talk about over the next few days. Cool. Hello.
Hi. What about like shared? What about a group shared like solution where different companies share the same distribution channels? Is that what you're thinking, or is it each company has their own?
So, the reality of where we're going, the next step, I think people want to own their own metaversey world that needs to communicate with other metaversey worlds. That's where I think the next step is. It's not where we want to end up, but where we want to end up is, there's lots of steps to get to that point. The way I see it right now is that there is a whole world internet out there, and nobody wants to rebuild the internet on a metaverse world. There's a whole bunch of risk behind that right now. So the next step is, how do I connect my internet with the metaverse world, and then start connecting those metaverse worlds to other metaverse worlds to create networks, and then start growing the metaverse that way. Because that way people can own the world they're building, own the content they're building, connect it to the content they've already got so they don't have to rebuild it all, and then they can start being part of the metaverse and taking advantage of what the metaverse brings.